Hello there, Nareg is here. Today we're gonna talk about how to study the variation of a rational function, but in this case it will be a function which is quite different than the two previous videos. In this case I'm gonna take the numerator 1 degree less than the denominator, but it's again a rational function. Once we're talking about a rational function, of course, we mean that we have a certain function f of x, which could be written as p of x over q of x. P of x, it represents a certain polynomial over q of x, another polynomial. Previously, we already talked about ax plus b over cx plus d. We talked about a certain rational function with an oblique asymptote. So right now we're going to take an example where p of x is 1 degree less than q of x. But first I'm going to talk about the steps that we are going to follow in order to study our rational function. The first one is to talk about the domain of definition. The second step is to calculate the limits. Now from the limits we can directly talk about the existence of the asymptotes, and of course the asymptotes could be vertical, horizontal, or simply oblique. The third one is to calculate the derivative. Now from the derivative we can of course deduce a table of variation. Later, the fourth step is to choose some particular points. Of course, these particular points are going to help me to draw my curve. Fifth step, if there is a certain symmetry, I can talk about the symmetry, and finally I will be able to draw the curve. Okay, so let's start. Let's take our example. The example is f of x is equal to x over x squared plus x minus 2. Now, the first thing is to talk about the domain of definition. We should say that x squared plus x minus 2 should be different than 0. Now, in order to factorize this equation, which is a second degree equation, it's a quadratic equation, we can go through delta, but there is a quicker way where you can simply check the coefficients. A is 1, B is 1, C is minus 2. So as you can see, you have A plus B plus C, which is equal to 0. So x1 will be 0, x1 it will be 1, and x2 will be C over A, which is minus 2 over 1, it will be minus 2. So we will have to reject the values. X should be different than 1, x2 different than minus 2. These are the two values that I should be, of course, taking them out of my domain of definition. So I will simply say d of f is from minus infinity to minus 2 union from minus 2 to minus 1 plus 1, and then from 1 to plus infinity. So this is how you find your domain of definition. Once you have done your domain of definition, you can calculate the limits, and of course in this case we're going to do the limit for minus infinity, for minus 2, 1, and plus infinity. So there are several limits that we are supposed to calculate. the limit when x tends towards minus infinity of my function x over x squared plus x minus 2. Of course, here we can choose the highest monomial limit of x tending towards minus infinity. It's x over x squared. You can simplify x and squared, so it will be 1 over minus infinity, which will give you 0 minus. Limit of x tending towards plus infinity, again of your function x over x squared plus x minus 2 is equal to the limit of x tending towards plus infinity of x over x squared. So it will be 1 over plus infinity, it's 0 plus. From here I can deduce that my limits give me y is equal to 0 as a horizontal asymptote. Horizontal asymptote. This is the first asymptote that I was able to find. Now, the limit when x tends towards minus 2 minus of x over x squared plus x minus 2, you will have to simply replace x by minus 2, so it will give you minus 2 over, in this case it will be 4. It's gonna give you 4 plus, of course, 4 minus plus minus 2 minus minus 2, so it will be minus 2 minus 2 over 0 plus. So it's minus infinity. Limit for x tending towards minus 2 plus of x over x squared plus x minus 2. Of course, once you do the replacement, it will give you minus 2 over 0 minus, it will be plus infinity. All right. Now, from this part, you can say that x is equal to minus 2 is a vertical asymptote. The same thing we're going to do for the limit when x tends towards 1 minus for x over x squared plus x minus 2. So we will have to replace by 1. Of course, in this case, since we have 1 minus, so we will have 1 over 0 minus, it will be minus infinity, and the limit when x tends towards 1 plus of x over x squared plus x minus 2, it will be 1 over 1 plus squared plus 1 plus minus 2, it will be 1 over 0 plus, so plus infinity. So again, x is equal to 1 will be your vertical asymptote. We have two vertical asymptotes, x is equal to 1, x is equal to minus 2, and our horizontal asymptote is y is equal to 0. So once you have calculated your limits, you can simply go and calculate the derivative. The function again is in the form of x over x squared minus plus x minus 2. It's simply in the form of f of x, which is u over v. Once you have f of x u over v, you will be able to say that f prime of x is actually u prime v minus u v prime over v squared. So u is equal to x and v is equal to x squared plus x minus 2. U is equal to 1, v prime, u prime is equal to 1, v prime is equal to 2x plus 1. So let's calculate f prime of x. So f prime of x is equal to x squared plus x minus 2 minus 2x plus 1 times x over x squared plus x minus 2 to the power of 2. So f prime of x is equal to x squared plus x minus 2 minus 2x squared minus x over x squared plus x minus 2 to the power of 2. So f prime of x will be equal to minus x squared minus 2 over x squared plus x minus 2 to the power of 2. Now, as you can see, the numerator is minus x squared minus 2, so it will have a negative value. It will be negative. The denominator is positive, so the whole fraction will be negative. For whatever value of x, it will be negative. So let's go and do the table of variation. So we're gonna say that x goes from minus infinity to plus infinity. The two critical values were minus 2 and 1. Now for f prime of x, again it is negative, negative, negative. Of course it can be, in this case it's shaded, here also it's shaded. So f of x, actually f of x will be decreasing, decreasing, and again decreasing. But of course in this part we have a certain discontinuity. It's discontinuous. Now we're gonna add the limits. The limit for minus infinity, if you can remember, it was 0. For plus infinity it was 0. For minus 2 it was minus infinity, plus infinity, and minus infinity, and here again it's plus infinity. So these are the limits that I have. My function will be decreasing, and of course we have discontinuity for -2 and 1. I'm gonna take some particular points also. Let's say f, my function is x over x squared plus x minus 2. F of 0 is 0. F of minus 1, it's 1 over 2. Alright. F of 2, again it's 1 over 2, and I can also add f of 3, which f of minus 3 is actually minus 3 over 4. So these are the particular points that I chose in this case. So I'm gonna simply add them to my curve. Alright, so we have the first asymptote is y is equal to 0, so it's the axis of abscissa. This is my first asymptote. It's a horizontal asymptote, of course, as you can see. For the vertical asymptote, I have -2. So it's -2. I'm going to repeat it again. And I have 1. These are the two asymptotes, vertical asymptotes that I have. Now, in this case, my function will be so decreasing, something like this, and then again decreasing, and then once again decreasing. So it will have a shape which is similar to this. Let's add our particular points. So what are the particular points? F of 0 is 0. F of 0 is 0. F of -1 is 1 over 2. -1 is 1 over 2. It's somewhere here. F of 2 is 1 over 2. F of 2. Again, it's 1 over 2. F of -3 is -3 over 4. So it's -3 over 4. It's somewhere near this point. So this is -1, let's say. It's -0.7. Alright. So my function will be decreasing, then once again decreasing, passing through the points that we already mentioned, and finally again decreasing. This is the shape of my curve. So as you can see, in this case my function had its numerator 1 degree less than the denominator, so we were able to have a shape like this. We have discontinuity for two values, x is equal to -2, x is equal to 1. Yeah, that's it for this function. So I'm going to ask you to subscribe to my channel. Of course, you'll be notified whenever I upload new videos. I can also share with you my Instagram or Facebook account if you want to contact me, ask me any questions, or simply leave a comment below. Thank you for watching and see you next time.